All right. Welcome, everybody. My name is Jorge Salamera, and today webinar it's about how to secure your Docker containers. Over the next 40 minutes or so, I'll guide you through a series of tips or recommendations that we got on how to secure your containers infrastructure. And we will cover like general recommendations, but we will go a little bit more into the details into Sysdig Falco. If you have any questions, just let me know. We have the QA feature, or we got the chat. There are some colleagues of mine there that will assist me and answering these questions, and I'll do my best to answer all of them. And as I said, all right, let's get started. Most probably, most of you know us, you know Sysdig, but it's worth mentioning just for a couple of seconds before getting started. Sysdig is an open source system troubleshooting tool that has native container support, and that makes it very special when working with Docker or Kubernetes or any other container platform. If you don't know Sysdig open source, it's probably easier if I tell you that it's a combination of HSOP, BMStat, NetStat, LSOF, TCPDime, and a few other like all these small Linux and Unix tools that you would be using for doing any kind of troubleshooting, they have been combined in one that in addition gives full visibility of what's your system or what are your containers doing. That's Sysdig Cloud. And this was so successful that we decided to create a commercial product out of it, and that's Sysdig Cloud. Sysdig Cloud is a monitoring, alerting, and troubleshooting tool for Docker, Kubernetes, Mesos, Rancheras, Google, ECS, any container platform that you might be using. So if you don't know us yet, please check us out in our website, and if you do, yay. Great, we hope you like it. But today it's not about Sysdig or Sysdig Cloud. Today I want to talk about Docker security and security in containers in general. But first of all, I would like to get a little bit into context. Traditionally, when we were deploying any application, we used to have this monolithic deployments where the operations team was managing the servers with the kernel, systemd, syslog-d, all the low-level stuff, and then ops teams, they had to deploy infrastructure services for the developers, MySQL or any other database, Nginx, and developers, they were asking for specific libraries like a specific version of OpenSSL or a specific version of Java. Then the devs, they were coming in and deploying their funky apps on top of our infrastructure. But we have seen that things are changing as we are starting to adopt containers. Ops teams, they keep doing what they do best, which is maintaining fully working and most of the time available infrastructure, while DevOps and developers, they have started to use containers so they can easily deploy the services they need to run in their application. So when they need a specific version of Nginx or OpenSSL or Java, they just need to deploy in your container platform. This is changing how we are approaching or how we have been traditionally approached to security. But probably the first thing we need to understand is that using containers and using microservices, it's not something new for us. If you look at how a car works or a computer, it's full of different systems that they are kind of black boxes because they do one function and then they interact with each other. So if you look at how you used to build your own personal computer a few years ago, you used to buy a motherboard, and then you used to buy some memory, and then a different CPU, and you used to build like all the different components all together, and there was some kind of compatibility protocols between them, and everything was working. So that was basically a microservice. Now, when we are talking, oh, we should be adopting microservices and we should run those into containers, it's not really that different. Still, the same security recommendations can be applied. That would be 4, which is establishing trust boundaries. And what do you trust when deploying things in your infrastructure? Identify, minimize, and harden attack surfaces. 3rd, reduce scope and access, and layers of protection and defenses. This still applies when using containers. But there is something new. And this is because when we try to apply defense in depth, it really works very well with microservices. Before, when we have monolithic applications, like everything or mostly everything had access to almost everything. Now with microservices, we have different small pieces that they do just one single service or one single function, and those services can be constrained into a container, and then we can apply the single responsibility principle. So we give that microservice running in that container the least privileges. We give the least sort of price, making all the defaults as secure as possible. And then we give it the least access as possible, because they just need to do one single function and provide one single service. Applying these 3 things, it's very easy. So we can do things much better in terms of security when using microservices on containers. But let's be a little bit more practical. Let's see what kind of things we can do when trying to apply security techniques on your container infrastructure. First of all, is that traditionally the workflows that you used to do before, it's going to change. Before, when you had to update your system, you were using the apt update or jam update. Now you're going to be doing Docker pull or providing a new version using Kubernetes or Mesos. So the workflow is changing a lot, and it's worth talking about in a specific area, which is continuous delivery and continuous integration pipeline. We have seen that that's very easy, or at least easier to do when running containers. We have Jenkins that can easily deploy my applications from a source code repository into my container platform and do rolling updates. OpenShift, we have seen how they have integrated that with the rebuilds and pipelines. So we'll see that applying updates both to our infrastructure services and also to the top-end application, it's way easier doing containers. Then we have all set of different tools to manage management, logging, and auditing. So, for example, Kubernetes and OpenShift, they provide user roles. So developers, they have access only to what exactly need to have access to. We can use namespaces to differentiate between production and staging or development scenarios. We can use centralized logging. Actually, we need to use it. There is no other way when doing containers. So these are kind of strategies that we need to adopt as well. Trust boundaries is one that is very interesting. We see that people, they really like Docker Hub because it's full of pre-built services, but do we trust everything that it's available there? And how we are sure that the image I'm downloaded hasn't been tempered. So Docker Hub and a set of different Docker technologies are improving that, providing specific policies on the repositories to being able to configure what kind of images you can deploy or you cannot deploy, or your developers can deploy or not deploy in your infrastructure, and then sign in the images. Another thing that's worth mentioning is simplifying your container operating system is a good thing to do. Using a traditional operating system that it's coming with a complete set of libraries, services, there is a lot of useless stuff that we don't need in a container that is doing a single thing. So there are projects like RancherOS, Red Hat, or Fedora Atomic, CoreOS, Alpine Linux, that they are quite handy at building a minimal operating system for your containers. You have network security, obviously applying firewalls to your container platform, all kind of things, and then secret management, because you need to share passwords, certificates, all kind of things like that. And for example, Bolt, it's very convenient, and environment variables they are not, because it can be hacked easily. There are a few other things we can do, but Docker provides some features for this. One is dropping capabilities as soon as you start your container. If an application doesn't need to run as root as in your container, don't do it. Like, containers are not VMs, so like escaping outside of a container is not that difficult, depending on the situation. So you should at least consider try to limit the number of applications that you run as root and the number of capabilities you provide to those containers. Docker has facilities to configure this very easily. Secrets, it's also something you can configure through Docker, and allows to limit the number of, or the amount of resources you assign to that specific container, so they cannot eat or consume all the resources of your host. Namespaces, they are also convenient to limit the scope of the visibility of your container. They can have their own process namespace. There are namespaces for different resources in the kernel. Lately, it has been released user namespaces that provides a complete different mapping between the users in your host and the users in your container. And that's something we need to start adopting as soon as possible, because really increases the security of your Docker containers. To configure all these things we have said before, Kubernetes and OpenShift and probably other container platforms provide something called security context that allow to configure all these things per pod or per namespace, so it's quite convenient. And then finally, another thing that is quite interesting and a must to do is host security. And actually, for example, Docker has an open source project that's called Docker Bench to analyze the security of your Docker host and make sure everything has been installed properly. But once we have applied all these things, can we say, are we running our containers in a secure way? Well, we can have, or we have applied a number of rules and a number of techniques, but how can I know what is happening inside those Docker containers? Well, we have two methods to do that. We have static scanning, and dynamic scanning. Static scanning is basically analyzing your containers before they are being run. So let's think of this scenario. You want to deploy a new service, you go to Docker Hub, you download the images, and you say, yay, this was so easy to deploy, I really love Docker Hub. And then you realize that your developers, they really love it too, and actually they are already using it for deploying services, at least in development. And then you go and you see how Docker images are built in Docker Hub, and you see that they are downloading software without any kind of HTTPS, no signature checking, no inventory to trace the versions that you run the software. It's a completely mess. And then you say, well, wait, is someone maintaining this image? How can I allow my developers to use services built on these kind of things that nobody has really control what they're doing well? So for that, we have static scanning. So we can analyze what's build each image from. So there are a few number of projects, open source projects like CoreScler, Docker Nautilus, that they are kind of like an antivirus that analyze the components inside of each Docker image. That basically it works because layer images, they are built on kind of different layers, one on top of each other. So if I have Ubuntu image and then I build an Apache image on top of my Ubuntu image, and then I build a PHP or WordPress image from that Apache image, I have like a tree of images, and then I can start scanning from the bottom up to the top, and in the moment that I see that there is one image that has a vulnerability, I can already mark all the images that depend on that as a vulnerable image. All these projects we saw before, basically what they do is they go to Debian Security Tracker, Red Hat Security Tracker, CVE vulnerability database, all these vulnerability databases, and then they take which are those vulnerabilities that we know, and they look for them inside of the images. And that's quite cool. So we say, okay, so I'm deploying images that they have been scanned, so I am secure. There are no vulnerabilities, but is that still completely secure? Well, it's not. Because containers, they are kind of black boxes that expose a functionality, an API, but inside still something wrong could be doing, either configuration, either my own application that's being deployed inside, or because there is already an intrusion and there is something funky going on. So that's why we have dynamic scanning. Dynamic scanning basically looks at what's happening inside those running containers in your infrastructure. And there are at least 3 projects or 3 ways to analyze what's going on a runtime: Seccomp, mandatory access control, and behavioral security monitoring. Let me go through this. Seccomp, it's basically application system called sandboxing. Seccomp is a feature available in the Linux kernel, and it's also integrated with Docker, and we can basically restrict the kind of sys calls that my container can perform. There is a restricted access mode that basically blocks most of the system calls, but at the same time, it's quite tricky because my applications or my containers, they need to open new connections or open new files, close previous files. So at the end, restricting these number of syscalls is, or bringing that into practice is not trivial, because application might be doing different things. We don't have much flexibility because it's syscall allowed or syscall not allowed. And as soon as my application or the container does a forbidden syscall, we kill that that process, therefore the container dies. So it's a good first step, but we can do better. That's why we have mandatory access control. Mandatory access control is basically bringing C-Linux or AppArmor security models to containers. It's the same mechanism, so we are intercepting syscall at the kernel level, and we are filtering those. But we have the capability to do more things, so we can combine that with given process, or we can configure which system calls are allowed based on files, read, write, or sockets, IPs, ports. So we have all these high-level concepts that they can be combined with the system calls to create these mechanisms or these filtering rules. The bad thing, or what the difficulty that comes with configuring Linux up or apart more, it's quite big. So the entry barrier to adopting this mechanism, it's considerable. So that's why exists a third method, and the third method is behavioral security monitoring. If we look around, probably in your houses, if you're at home at the moment, or in the office, one of the most widely adopted security mechanism, it's video surveillance. So we have cameras everywhere that they are looking at what we are doing, what people visiting are doing, and probably you might have one of those at home. Obviously, we have doors, we have keys, but keeping an eye of how things are working and to see if there is any intrusion or a suspicious or anomalous behavior inside your containers is a step very easy to take. This is a methodology very easy to adopt. So that's the difference between enforcement, as we saw before, and auditing now. Now we only watch, and we will be triggering alerts when things that we can consider an intrusion are happening inside of our containers. We do that, again, building a rule set. And for doing this kind of things, we have either Audit D, which is the Linux logger daemon, or Sysdig Falco, which is the tool we have built. So, and this is where I'm going to look a bit on the details of Sysdig Falco. Sysdig Falco is an anomaly detection system built on top of the Sysdig engine, as I mentioned before. And if you don't know how Sysdig works, basically what we do is to do a kernel module that instruments all the system calls. We are able to intercept all the system calls. We copy them into a shared memory buffer, and then we have a user space application that collects all the system calls from that buffer, and we can do all kind of things. And one of the advantages of Sysdig Falco is that, yes, obviously, we can detect any kind of suspicious activity with an easy rule set. It's very flexible because it runs in user space, so we can use all kind of libraries and high-level libraries that we cannot introduce inside of the kernel. And this is the third point, probably the most important here. We have knowledge and we have information of how is your infrastructure running and how you are deploying your containers. We can talk to Kubernetes, we can talk to to Docker, to Kubernetes, to Mesas, to any container platform that you're running. We know how you are deploying containers there. So we can use that information inside of the rule set to define that suspicious activity and trigger alerts. We'll see that we can send alert to multiple ways, and all this technology, all this project, it's fully open source. So we would like to invite you to go to our GitHub repository, a link for that later, and have a look at the source code, contribute some rules, or even contribute some patches and new features to Sysdig Falco. Let me show you a few quick examples how easy it is to create rules for Sysdig Falco. So for example, if we want to create a rule that will send us an alert when a shell runs inside of a container, we do like this. Okay, if the container ID is not the host, because the host it's fine to do SSH and open a shell, and then there is a process named bash. We can say bash, but any shell could be included here through a list. Then we will trigger an alert. Now, there's another interesting example. Like, let's see how I can get an alert if any process tries to do a write in one of the system binary directories. So it's just as easy as doing fd directory in this array and then write operation. This will trigger an alert. If someone inside a Docker container is trying to jump outside and is doing funky things with the namespaces, for example, changing namespaces, so we can also trigger an alert. So if there is an event that it's doing a set namespace, and the process name is not Docker or Sysdig, which are the only allowed tools that they should be doing that, trigger an alert. So I'm not going to continue with these examples. You can see them, but this gives you a feeling how easy it is to write security rules for Sysdig Falco. If you're familiar with Sysdig or even with TCP/DAN, you will see that the syntax is pretty similar. This is a full rule inside my Falco configuration. So I create a macro to globe my system binaries directories, bin, sbin, usbin, and your user sbin. And then I create another list with some package management binaries. So Debian package or RPM, so I can cover multiple operating systems. And then I'm going to write a rule. So if I'm giving the name, write binary directory, and I can do a description. And then I do a condition. If there is a binary there inside of this macro, and there is an event that it's doing an open write, and it's not from one of these programs that I have whitelisted, I want to trigger this output field below a non-binary directory open for writing, and some information and some priority. So this will trigger an alert, and then these alerts can be sent to either syslog, to any file, standard output, show, and then send an emails, or send to a system that you might have, or send to Sysdig code if you already use. So that's a few good examples to give you a taste of how Sysdig Falco works. But I want to show you a demo today. It won't be long, but it's going to be good to give you a feeling. What I have here is a Docker Composer scenario with a Node.js application and my Falco container that it's basically listen for system calls in all containers running in my host. So I'm going to run, oh, sorry, I want this to be bigger. So I'm going to run this.
Hey, Jorge,
yes?
before we get started with the demo, I think now
yes.
is the time to pause for some questions. So
excellent.
It looks like we just had a question that came in from Brian. Can you apply those rules only against a certain containers or exclude alerts from containers that match your regex?
Yes, exactly. If we look back into this slide, when we do container.id, here we can use your Docker container name. So we could do if container.id equals Node.js express, for example, this container I got, then the rule would be applying only to that specific container. Next, do we have any other questions?
Not right now, but anyone in the audience, now's a great time to kind of send in any questions that you may have had during the slides before we get to the demo. And then I'm going to follow up in the chat with a link to the default rule set, and so you can kind of see a more complete list of all the different types of rules and how they can be used. So that might be something good to look at while the demo is going on and kind of spur some other questions that might come to mind.
Excellent. In any case, after the demo, we'll also stop a couple of minutes to see if we got more questions. All right, so I'm going to start this scenario with my Express, Node.js server, and Falco. This is building my Node.js already running. Falco is already running. So my Node.js application works. So there is a new developer in the company who's not very trained on defensive and security best practices when coding, and he came up with this function that basically runs on the container any command that goes through this URL. So what I'm going to do is to let me demo this. So if I do an ls, this is basically running an ls on the current directory of the Node.js application. But look what happens if I run a shell. That's interesting here. This is showing my host. So, okay, if I run here, I see Falco triggering alert warning. Shell spam in a container other than entry point. And this is given here the Docker ID. Let me show you. So exactly this one, 107, 107. So let's imagine I got a backdoor already on this container, and I have a shell. Let's pretend I'm inside. Okay, so if I try to do something like creating a file in one of these system binary directories, it works, but here I get another of these Falco rules. Warning file below a known binary directory open for writing. And I got the user, the command, and the file. So if I wanted to do rules for outgoing connections that shouldn't be there, basically anything, this is something you can configure on Sysdig Falco. So let me show you the default rule set. So it's something like that. I have a number of open, write, open, read, rename, modified. So I got all these rules already created, and then I can add more for outgoing connections or things like that. All right. So let me go back to this. If there is one thing I want you to remember from this presentation, is that container behavior security shouldn't be difficult. So that's why we have created Sysdig Falco with that YAML format, rule set, high-level TCP/DUM Sysdig or Sysdig-like format. So you can start deploying security monitoring rules across your infrastructure, just running your Falco container, applying the rule set, and easily you can recover or you can get notified when there is anything that can be an intrusion on your infrastructure. If you want to learn more about Sysdig Falco, we have quite complete documentation on sysdig.org/Falco. Or if you go to our GitHub repository, you will be able to also look at the default rule set and how we are making contributions. So this is pretty much what I had today to show you. Knox, I don't know if we have any other question at this point.
Yep. So Jorge, there's a question that just came in that said, so it reports that bash was ran, but does not prevent it from running.
No, Sysdig Falco, it's only behavior monitoring tool. So we don't block that system calls. If you want to block system calls, you need to go to those complex mandatory access control systems like SE Linux or AppArmor. Both are available as Docker profiles. So it's there, but the complexity of applying those into production should be considered. That's why we created Sysdig Falco, that it does only monitoring. But as I said before, monitoring is already a huge step towards keeping an eye on monitoring what's going on inside your containers. Knox, do we have any other question today?
Yeah, so another question came in. Can monitoring rules be changed dynamically? Do they require restarting services?
To reload a new rule set, we can either restart with a rolling deployment. Obviously, we are using Kubernetes and things like that, our Falco container, but Falco can also run outside of a container. In this case, in my scenario, it was running inside a container, but it's also available as a Debian package or CentOS package, and then it's just a reload of the daemon. So when running inside a container, usually you do a container restart, but you can send a signal to the process and we'll reload the configuration file and apply the new rule set.
And then one last question. Does Sysdig Falco integrate with any of your other services?
So Sysdig Falco can send alerts anywhere through the shell output method. So because using that, you can send an email, you can send a payload to any API. But with Sysdig Cloud, we offer already working integration. So if you know Sysdig Cloud, you will know that we have an events section where you can see what are your containers doing. If you start a container, you stop a container, or Kubernetes or Mesos or any platform is scaling up and down containers, things like that. So in that very same timeline, you can get Sysdig Falco events sent to Sysdig Falco. Sorry, to Sysdig Cloud. So yeah, short answer, yes, it's integrated with Sysdig Cloud.
Awesome, thank you. That's about it for the questions that we have so far. If you guys have any more, we're going to be around for the next couple of minutes, so please send them in. And thanks for joining today.
Thanks for joining.